All right, when we have a scatter plot, we are comparing two different sets of data, and we can plot them as ordered pairs. So in an ordered pair, we've got an X, we've got a Y. What was another word for the X values of an ordered pair that we talked about yesterday? Zach? X values. Seth? One way that we can refer to these ordered pairs is as the domain and range. What's another? There are 4 different ways if you include X and Y. What's another something I can refer to my X values? Seth? Okay, besides X. We have X, we have domain, what else? There are 2 other things that we could call these X values. We talked about them yesterday. This was in our quiz. We talked about, we have X and Y, domain and range. The X values are the values that we put into our function. So what do we refer to our X values as? What? Okay, X is the horizontal axis on our graph. What else do we refer to those X coordinates as? They are what we put into our function. What? Okay, they're numbers, but that could be anything. Values can refer to anything. Specifically, what are our X values? What we put into our function. Values we put into our function. This was the first question on our quiz yesterday. What? Values we put into our function. I'd start flipping through your section. Some of you are staring at me like I'm a monkey that's going to do a trick. I'm not. Start flipping through your book and find something that we call those X values. I'm going to stand here and wait for you. Flip through this section. Flip through the next sections. It's in this chapter. What do we call the X values or the domain? Jacob? Nope. That has nothing to do with X values. That's the whole thing. It's a whole set of ordered pairs. It's not correlation. Nope. That talks about how the sets of data are related. Seth?
Independent.
That's one way. One way. That's not the only, so keep looking. One way is to refer to the X as the independent, and Y is the dependent. The Y value depends on the X value. So whatever our X value is, that's going to tell us what the Y value is that goes with it. You should still be flipping through your book. Some of you are still staring. Start flipping pages or we will not move on. You will not have time to do homework at the end. Alex? Input and output. The X values are what we put into our function, and the Y values are what we get out. So these are going to be more this input, output when we start talking about those relations and those functions, but those are all terms that we can use to describe these ordered pairs. When we're talking about scatter plots, the dependent variable is going to go on the y-axis. The independent variable is going to go on the x-axis. We talk about domain and range, what I put into my function and what I get out of my function. That's what these ordered pairs represent. So looking at this table that we are given for this example number 1, what are my x values going to represent in this problem? Seth? Hours. So my x values are going to be the number of hours. which means what are my y values going to be, Jacob? And what is that? What does that represent?
Dollars.
Dollars what? You may have to read the words. It's not amount of money that we are spending. It's the amount of money that we earn. So we're working at some job. We work a certain number of hours, and however many hours I work, that tells me how much money I'm going to make. So now we need to graph it. And when you graph these, there are a few specific things you are going to need to label on your graph. First of all, am I going to work a negative amount of hours? Am I going to earn a negative amount of money? No. So we're going to make our axes on the corners of our graph. And this is, scatter plots are always going to deal with real life data. And most of the time, that real life data is going to be positive. Not always, because you could track temperatures, you could track stocks, which can go up and down in money. But most of the time, we're only going to be interested in these positive values. The next thing that we need to do is we need to label each of our axes. So we've got our x and we've got our y. And we need to label these in words. We've already said x values is the number of hours. So I'm going to put on my graph, what does this x-axis represent? It represents the hours that I've worked. Then we also have to put what our y values represent, which is the money that we earn. So we work some hours, that's going to get plotted on the x-axis. That's going to tell me how many hours I earn, which is on the x-axis. Now I've got to figure out what scale I want to use. What is the minimum possible hours that I could work at this job? It is not 6. What is the minimum possible hours that I could work? Seth? That's the minimum. Joe? 0. I could work 0 hours. Now we need to think about our data. What is the maximum amount of hours that I'm looking at here? Zach? 15. So my hours need to go from 0 to 15. So now I need to look at this graph, and I'm not going a real long way. 0 to 15 isn't a lot of numbers. I'm just going to go by ones. So I'm going to say each small line here represents 1 hour that I have worked. So each bold line represents 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each small line I'm going to say is 1 number, 1 unit. Now when I start thinking about the money that I earned, what's the minimum amount of money that I could earn? Zach?
0.
0. If I work 0 hours, I'm going to get $0. What's the maximum amount of money, Seth? $63.75. So now I need to think on my y-axis, I need to think of a scale that's going to fit all of these values onto my graph. So what should I go by on this y-axis? Zach? 15 as each little line or for the big lines? For the big lines you did 15, so we'd have 15, 30, 45, 60. Is that going to get us to our highest value?
No, I go like charts.
You had to go off the chart, so what could I go by instead?
20.
I could go by 20s. I could say this is 20, 40, 60, and 80. What would each small line be if I went by 20s for the big ones? So we have to think about how many there are. Who said 4? 4 what? Are we going by 4 or are there 4 lines? What? So each one will represent $4? How did you get that?
I divided 20 by 5.
Perfect. So if I divide 20, there's 1, 2, 3, 4, 5 small lines. 20 divided by 5 is 4. So each of these lines represents $4. 4, 8, 12, 16, 20, 24, 28, and we can keep going. So now we've labeled both of our axes, the x and the y. We have picked a scale that matches our data, and now I have to plot my points. What is one ordered pair that I should plot on this graph? Will, what's an ordered pair that I should plot? So 6 will be the X value, 25, 50 will be the Y. 6, and here's 20, 24, so it's going to be somewhere there. These points don't have to be perfect. We're just taking this real life data, we're putting it, I'm talking about decimals and quarters and 3/4 and halves, so I'm just going to get as close as I can. What's another ordered pair I could plot? Graham?
12 and 51.
So I've got 12, I'm going to go 40, here's 48, so maybe somewhere around there. Dante, what's another ordered pair I could plot?
46.
So here's 44, 48. Greg, what's another one? Seth, what's another one?
9, 38.
I just did that one. 15, and then I'm going up 63, 75. Any more? Can I plot anything else? Jacob?
10, 46.
Here is my scatter plot. When we are creating these scatter plots, we don't want to connect our points. We're not drawing lines in between our points. We're not just connecting them all. We are simply graphing our points on our graph. We're taking those X and those Y values, and we're creating points on our graph. You must label your axes, and you must be able to tell me what your scale is. The X, we're going from 0 to 15. That's the numbers I have to fit on my graph. Y's, I have to fit 0 to 63, 75. So I'm going to go up by 20s each time. So make sure you can label your axes and pick a scale. Are you going by 1s like we did on the X? Are we going by 4s or 20s? Or what are we going to go by to fit everything? And then get your points as close as possible. So now that we've graphed it, let's talk about how we can compare these graphs, how we can compare this data. When we talk about correlation, we are talking about how are our sets of data related. And a trend line is going to help us see that relation between these sets of data. So, positive correlation, they both increase. As my X's are getting bigger, my Y's are getting bigger. And as I read from left to right, my arrow is going to point up. It's a positive correlation, I am increasing. Negative correlation, as my X's get larger, my Y's are getting smaller. So as I move from left to right, my arrow is pointing down, and I have a negative correlation. No correlation, I'm going to have all these points scattered all over my graph. They're not related. There's no trend line. If I draw that trend line, there are points all over the place. And when I draw that trend line, I just want to put it right down the middle of my points. So I'm not trying to hit every point. You don't have to hit any points on your graph. You want to pick the middle, and we just want to draw a straight line through the middle of those points. We call it a line because we are drawing a line. We don't want it to curve. We don't want it to have angles. We just want to draw a straight line. So I can draw this trend line. I can draw a trend line in this graph, just going right through the middle of all those points. This one, there is no trend line that I can draw. These points are all over the place. So there's not really a trend in this data. These sets are not related. Let's go back to our data on our first graph. What type of correlation do I see between these two sets of data? Joe? Positive. Why? They both increase. And does it make more sense that the more hours I work, the more money I'm going to make? And it doesn't matter what type of job you have, whether you're working a cash register at a store, or you're a lawyer, or a doctor, or an engineer, the more hours that you work, the more money you are going to make. Your salary doesn't matter. It is just in general. If I draw that trend line, I can see that it's pointing up. And this goes through just about all of these points here. So they are very closely related. They're probably all working at the same job. So now let's look at this problem here. And we are comparing the average acres of the farm compared to the number of farms. Who wants to come draw our trend line up here? Somebody want to volunteer to draw the trend line? Zach, you want to do it? All right, good. Draw our trend line for us.
Does it always have to start from the bottom right corner where 0 is? Or can you go from the top corner or the...
You're just drawing a line through the middle of the data. So this one,
It's just from the top. It's negative.
I think your first one was a little bit better,
Yeah,
actually.
but my first one was like curvy, like a snake.
I think it'd be more like, I wonder if I can rotate this. It'd be more like that, right there. All right. So, Seth, why do you say it's a negative correlation? Okay, and how do I know? As the number of acres,
Decreases.
what decreases?
The number of farms decrease with average acres. Because it gets smaller. That's all I know because it gets smaller.
Okay, so as the average acres increases, as our X values get bigger, our Y values get smaller. So as the average acres increases, the number of farms decreases, which means we have a negative correlation. Now I need to figure out, I want to predict the number of US farms when the acres is about 500. Which value, X or Y, is going to be 500? X. Acres is the X value, so I'm looking at when X is 500, if I extend this trend line, when X is 500, what is my Y value? It's about 1,000, and I'd say anywhere between 1,000 to 1,500. It just depends on where you draw your trend line. Yeah, still a lot of farms. So if you have 500 acres of farm, you're going to have about 1,000 to 1,500 farms that are that acre. So we just use our trend line to find when my X value is 500, what is my Y value on that trend line. I want to look at one more problem like that. This is a graph, this is a generated graph from Excel of the problem we talked about in example 1. So we're comparing the amount of hours that we work to the amount of money that we are going to make. If a person earns $58.50, what value does that represent? Okay, so I need to look on my y-axis at 58.50. I'm going to guess it's about right there. I can draw my trend line through these points. Got a little curvy up the top. Now, how am I going to figure out how many hours they worked? Jacob? Graham? So like right here? And then how am I going to figure out that number of hours? Where do I look? So which values? The X value. So I'm trying to see what is the X value when the Y is 58.50. And I'd say 13 to 14-ish. Somewhere around 13 to 14 hours. So I can use that trend line. I can use my graph to see if they earn this amount of money, how many hours did they work? Questions about scatterplots or correlations. If they both increase, if the hours and the amount both get bigger, then it's positive. If the X value increases and the Y value decreases, then it's negative. If these points are all over the place, all over the graph, then they're not related at all. Yes, that is your question. So, yep, if they're just random points all over the place, if we're talking about maybe how many desks are in this room compared to how many classrooms are in the school, is that really going to matter? Does one have anything to do with the other? No. So that would have no correlation. If we selected a bunch of schools, it would probably be all over the place. It wouldn't matter because one has nothing to do with the other. Here is your homework.